So here's a basic question. Why is DRAM so much cheaper than SRAM? Well, the fundamental reason is that DRAM memory cells are much smaller. And if something's much smaller, we can make a lot more of it on a chip, which means it's going to be a lot cheaper. And we can take a look at why that is. So DRAM is smaller because it's cheaper. Here's the output we're going to have from our memory. And in SRAM, remember we have these back-to-back inverters, which are going to store the value in them by inverting it around in a loop. In DRAM, however, we have the same output, we just have one capacitor. And so if you compare them, SRAM needs to have two small inverters for each one of its bits, whereas DRAM just needs a tiny little capacitor for each bit. And of course, this has different values on performance. The DRAM is going to be very slow because there's very little charge here to come out on this wire to change the output. Whereas the SRAM, these are powered inverters. They're connected up to the power, so they can drive their charge out onto the output much faster, so it will be much faster. Let's take a look at latches and clocks. Here we've got a latch here. What signals do we put into A and B to build a latch that stores data on the falling edge of the clock? Well, for this we want to put clock into A. So what that means is that when clock is true, it's going to allow the value into the beginning of the latch. And then when the clock, but it's not going to allow it all the way through because this is not clock. So when clock is true, it's going to come in here. And then when clock changes from true to false, that is it goes down, this is going to open, so the value is going to stay in here. This is going to close and the value is going to go out. So we want to make sure that A should be closed when the clock is high and B should be closed when the clock is low. Let's take a look at DRAMs in the future. So DRAM cells are continuing to get smaller. There are fewer and fewer electrons in each bit in the DRAM. What does this mean? What's going to happen? Well, the answer is here that all of these are true. The DRAM will become less reliable. There are fewer electrons in there. It's harder to read out the value accurately. The DRAM will become slower. Well, if there are fewer electrons, we may have to wait longer to see it come out. And the DRAM is more sensitive to cosmic rays. So if a cosmic ray hits and leaves random electrons, if we have very few to start with, we are going to be more sensitive to it. So all of the above.